Let's take a look at some examples for Chapter 7. Starting off with true and false questions. Continuous random variables can take on values between whole integers that contain decimal points. That is true. For continuous distributions, the probability that x is less than or equal to a value m is the same as the probability that x is less than that value. That is also true. The z-score follows a normal distribution with mu equal to 1 and sigma equal to 0, which is known as the standard normal probability distribution. This is false. The z-score follows standard normal distribution. With the continuous uniform probability distribution, the probability that any interval in the distribution is equal to any other interval with the same width, that is true. Moving on to multiple choice questions. The what probability distribution is bell-shaped and symmetrical? This is the normal distribution. Which of the following statement is true regarding the normal probability distribution? The mean, the median are roughly equal to one another. Which of the following statements is true regarding z-scores for the normal probability distribution? This would be A, where the z-scores are negative for values of x that are less than the distribution mean. For number 4, the time for a professor to grade an exam is normally distributed with mu equal to 16.3, mu is equal to 16.3, sigma is equal to 4.2. What is the probability that a randomly selected exam will require less than 20 minutes? So I'm looking for the probability of x to be less than 20. You do your graph. The mu is 16.3, 20 is to the right, less than 20, I'm looking for this area. Now, we calculate the z-score. The next step is to calculate the z-score. The z-score will be equal to 20 minus 16.3 over sigma. So we have 0.881. 0.881, you will round up to 2 decimals, 0.88. So for 0.88, you go to your table, 0.88, 0.3106, 0.3106. This is not, however, the area I'm looking for. I'm looking for the whole area. I already know that this part is 0.5, so the probability that I'm looking for will be equal to 0.5 plus 0.3106. So the correct answer in this case will be 0.8106, which is C. The time for a professor to grade an exam is normally distributed with a mean, same problem, equal to 16.3, sigma equal to 4.2. What is the probability that a randomly selected exam will require more than 15? More than 15, x greater than 15. Once again, you draw the normal curve. Mu is 16.3. 15 is to the left of the mean, less than the mean. And I'm looking for the area where is greater than 15. Greater than 15 means the area, the whole area to the right of 15. Z-score is equal to 15 minus 16.3 over 4.2. So let's do the calculations. 15 minus 16.3 divided by 4.2. This is going to be negative 0.3095. Again, you round up to 2 decimals, negative 0.31. Negative 0.31, you take the absolute value, 0.31, 0.1217. 0.1217. So the probability that we are looking for will be 0.1217 plus 0.5. So this is going to be 0.6217 for the probability I'm looking for. Keep in mind, the mean is inside the area you're looking for, so you are adding the corresponding probabilities. Bob's golf score follows the normal distribution with a mean of 92.1 and the standard deviation sigma equal to 3.8. What is the probability that the next score will be more than 90? So I'm looking for the probability of x to be greater than 90. Normal distribution, mu is 92.1. Sigma, we're looking for the probability of x to be greater than 90. 90 is to the left of the mean, greater than 90. I'm looking for the whole area to the right. Z-score, 90 minus 92.1 over 3.8. So this is going to be equal to negative 0.5526. So you round up to 2 decimals, negative 0.55. You go to your table, you look up 0.55. 0.5 is here. You move across to 05, 0.2088. 0.2088 is this area. Keep in mind that whatever probability you get from the z-score is the area from the mean to the value. This is part of the area, however, you're looking for, not the answer. You have to still add 0.5 to find the whole area. 0.5 plus 0.2088, the correct answer will be C. The time that customers wait to be served at a delicatessen for a grocery store follows the uniform distribution between 0 and 7. What is the probability that a randomly selected customer will wait more than 4 minutes? So x greater than 4. So if we were to graph 0 to 7, 4, let's say is here, greater than x greater than 4, I'm looking for this area. So this probability would be equal to 7 minus 4 over 7 minus 0. So the correct answer would be 0.4248. Now, as far as the problems are concerned, according to the American Consumer Satisfaction Index, airlines received an average satisfaction score of 65 last year on a scale of 0 to 100. Assume that this satisfaction score is normally distributed with standard deviation of 13.5. What is the probability that a randomly selected respondent rated airline satisfaction with a score less than 45? So I'm looking for the probability of x to be less than 45. We draw the normal curve. Mu is 65, 45 is to the left of the mean, less than 45. I'm looking for a left tail. We calculate the z-score. X is 45 minus 65 over sigma. Sigma in our case is 13.5. Your z-score will be negative 1.48. Negative 1.48, you take the absolute value, you check your table for 1.48. This will give you a probability of 0.4306. So to find this area, since you're looking for a tail, you will be subtracting from 0.5 minus 0.4306, and this will be equal to 0.0694. So this area here will be 0.0694, which is also your solution. According to a survey conducted by Big Inside, women who celebrated Valentine's Day last year spent an average of $86. Assume that this cost is normally distributed with a standard deviation of 27. What is the probability that a randomly selected woman who celebrated Valentine's Day spent between 60 and 80? So I'm looking for the probability that X is between 60 and 80. Mu is 86. Both 60 and 80 are to the left. I'm looking for this area. Keep in mind, when you're looking for an area between two values where the mean is outside the area you're looking for, at the end you will be subtracting the corresponding probabilities. So let's go ahead and find the z-score for 60. 60 minus 86 over 27. This is negative 0.96. The z-score for 80. 80 minus 86 over 27. This will be equal to negative 0.22. You take the absolute values of the two and you check the corresponding values from your table. So this will be equal to 0.3315 minus 0.0871, which will give us 0.2444. So 0.96 z-score has a corresponding probability of 0.3315. 0.22 z-score has a corresponding probability of 0.0871. We subtract, and the area that we are looking for will have 0.244 for the probability. Now, according to the Consumer Reports, the average annual out-of-pocket cost for an implant for Americans who have dental insurance is $2,825 last year. Assume that this cost follows the normal distribution with a standard deviation of 270. What is the probability that a randomly selected American who has dental insurance will spend between $2,700 and $3,200 for an implant? So we have the mean, 2,865, and I'm looking for the area between 2,700 and 3,200. So I'm looking for this area. Whenever we have, whenever we're looking for an area between two values where the mean is inside that area, always remember that at the end you will be adding the probabilities that you get from your table. So the z-score for 2,700 will be negative 0.46, and then we calculate the z-score for 3,200, and this is going to be 1.39. This is when you go to your z-table, you find the corresponding probability for 0.46, you find the corresponding probability for 1.39, and then you add them. If you do that, you will end up with 0.1772 plus 0.4177, 0.5949, your answer 0.5949 for the probability. So this will be your answer. Number 4, the amount of time golfers spend hitting golf balls at a driving range is uniformly distributed between 25 and 50 minutes. So 25 is your alpha, 50 is your Vita or B, what is the probability that a randomly selected golfer will spend between 30 and 37 minutes at the driving range? So I'm looking for this probability. You draw your graph, uniform distribution from 25 to 50, the area between these two values. So the probability will be 37 minus 30 over 50 minus 25. So 37 minus 30 over 50 minus 25. So the probability will be 0.28. The total time, problem number 5, the total time that customers spend in line and being checked out by the cashier at a grocery store follows the uniform probability distribution between 4 and 13 minutes. What is the probability that a randomly selected customer will spend between 5 and 9 minutes waiting in line to check out? So alpha is 4, Vita is 13. I'm looking for this probability. So all I need to do is 9 minus 5 over Vita minus alpha, 13 minus 4. So the answer will be 0.444. And these are the examples for chapter 7.